Hello everyone, this is the first tutorial for Arduino Uno. In this tutorial, you will learn about interfacing of LED with Arduino Uno. So blinking LED is common tutorial for every microcontroller to verify functionally that controller is working or not working. So in this session, you will learn about what is LED. When LED is connected to digital pin of Arduino Uno, it's connected via resistor. So what is the significance of the resistor? How its value is calculated? It's connected either in series or in parallel. Why LED is connected to always digital pin, not to analog one? Then there is a different hardware configurations while connecting to the LED to Arduino Uno, like current sink and current source. So which one should be preferred? So we'll see practical demonstrations of entire hardware connections along with in details line by line code explanations. For this tutorial, we require the components are Arduino Uno, that is our main controller, and few LED of any colors, then some jumpers wires to make the wired connections, then register which having the some specific value that we'll see next. And to make this all wire connection, we can prefer either breadboard or zero PCB, but we will go for breadboard since to make the connection simple and easy, it's possible using breadboard compared to zero PCB, which were required the soldering. As we know, LED is nothing but light emitting diode, which has a two terminals for positive and negative supplies. So cathode is nothing but the negative terminals which connected to the ground of Arduino Uno, whereas the anode it is the positive terminal of the LED which is connected to the digital pin of the Arduino Uno via resistor. At a beginner level, there is always confusion how to identify which one is a positive and which one is a negative terminal of the LED. So if you look for LED, you will simply notice that the terminal which is longer in length, it's anode or positive terminal. The others one, which having the shorter in length, it's a negative terminal, that is a cathode. But in case both terminal are the same length, then in that case there is a flat spot near to the cathode which can easily identify. As a pressure, there is always question why LED is always connected to the digital pin, not to the analog pin. You see the digital signal like square wave, it has only two values, 1 and 0, high or low. So every digital device which process only these signals, or it's known as a digital device. So LED is a digital since it is either on or off at every instant of the time. That's why it's a digital device. It's come into category of the digital devices. If we compare it with the analog signal, which having the infinite values with the finite times. So the device which process or generate this signal, it's an analog one. Like there are different sensors, temperature, humidity, moisture sensors, or multiple transducer, which comes into category of the analog devices. When LED is connected to digital pin of Arduino, it's connected via resistance. As we saw, the hardware connection is made using breadboard. So when we are making the hardware connections, so breadboard will be preferred over the zero PCB. So inside the breadboard, there is the outer points and the inner points. So outer points are shorted horizontally. These all points are horizontally shorted, whereas inner points are shorted vertically. So both sides of the outer point shorted horizontally. While interfacing LED with Arduino Uno, we are always using resistor since resistor used to limit excessive current flowing from Arduino pin to LED. So it will prevent both Arduino Uno as well as LED also. There are multiple value of registers are available 100 ohm, 1K, 100K, but which one should prefer while making the hardware connections? That will be depends upon two factor. One is dropping voltage across the LED and current consumptions of the LED. So dropping voltage will depends upon the color of LED, either it's red or blue, as well as the size of the LED. So for red LED it's a 2 volt, whereas the blue LED it's a 3 volt. And current consumptions of the LED will be in the range of 15 milliampere to 20 milliampere, but we will consider here around 15 milliampere. So using current consumptions and dropping voltage in Ohm's law, we will calculate the value of the resistor. So as per the Ohm's law, which is voltage divided by the current, we will get the actual resistor's value. So voltage, that is dropping voltage, should be subtracted from the source voltage, that is a 5 volt in our case. So we will get the 200 ohms resistor. So any value of the resistor in between 200 ohm to 300 ohm we will prefer while making the connections of LED with the Arduino Uno pins. When we are making the connections of the LED to Arduino Uno pin, resistor is always connected in series as it's working current limiting resistor, so it should not connect across the LED. So for the parallel connections, we will always prefer the series connections. To create circuit diagram for hardware connections, so inside Arduino Uno, this section represent digital pins, whereas these are the analog pins. These are the power section. So we can connect any of the pin from this digital section to LED via register. So we will connect pin number 10 to positive pins of the LED, that is anode, whereas the cathode is connected to the ground of LED. Let's start to write program. Code we can rewrite as per the circuit diagram we have made for actual hardware connections. So we can keep it aside for our reference. So as we open the softwares, so initially you will see there is a setup and loop. These two functions you can see. The setup one, which where we write our code, which will execute only once, and the loop, it is the function where whatever the logic that we have written, it's executed cyclically, it's repeatedly. So inside the setup we have to write the whatever the pins that we have used, either input or outputs. So along with the pins, whatever the modes that we have to define, that we need to execute only once, that should not execute repeatedly. What are the initializations of the specific variables, so whatever the parts of the program that we require to execute only once, that's we put into the setup, while our main core logic, that is comes into the loop. So before two setups, we should take the habit that giving the declarations for the particular pins that we need to use, giving the specific meaningful names of the particular pins that we are using for the LED or any of the sensors. So in future, before to set up, we need to give the declarations for the whatever the pins that we are using. In future, suppose instead of the single pin, if you are going to use multiple pins, so declaration will help us to easily identify the which pin is going for what sensors or any output device. So for that LED, we have to connect it here as per the circuit diagram. Pin number 10, it's connected to the anode of the LED. So we need to define here the LED pin number 10. Then inside the setup, we need to use the function setup. It is the one which is executed only once. So pinMode is the function we need to use, which basically define the pin status. Either it can be used as an input or output. So LED is the output device here in our case. We need to define the particular pin, that is pin number 10, which will given the name as a LED pin as a output. It's a case sensitive. So whenever you have write the program, you should aware about whatever the alphabets you have used, it's used correctly. pinMode with LED pin, that is we have already defined as a pin number 10, which is giving the output, and end with the semicolon. Here for commenting we are using the double slash function, which have I am writing here the syntax for the pinMode. Here pin comma whatever the mode that we want, either inputs or output that we need to define, and the end with the semicolon. Okay, so LED we have defined as the output. Then inside the cyclic functions, that is the loop one, where we have to write logic. So we need to toggle the LED. So LED is on and off with specific time delay. So we need to toggle this pin. For that purpose, we need to use function digitalWrite. So this function we need to use to toggle the pins of the LED. So the digitalWrite basically the function which can write whatever the value that we have provided in this function as argument on the respective pin. With LED pin comma, we need to on the LED with giving the some delay to keep holding that on, whatever the turn on is LED is there, it should be stay on for particular time delay. So that's why we have kept 1000 millisecond, that is 1 second, and after the 1 second we will keep it as off. So this is to LED on, and this is to LED off. Yeah, that's it guys. So in this way 1 second we will keep it on, and after 1 second it will becomes off. So in this way on and off, after with the delay of the 1 second, LED will be toggled, so it will generate the square wave, we can say that, on the digital write pins. Before to flash, we'll first save this code. Link tutorial, it will take time to save. Let's do the actual hardware configurations by connecting all components.
Let's start hardware connection. First we will connect LED on breadboard. After that we will connect one terminal of resistor to anode of LED, and other terminal will be connected to digital pin 10 through jumper wire. So before connecting to jumper wire, first we will make the connections of jumper wire on Arduino board. So here we are connecting black wire to ground and red wire to pin number 10. So it's done. After that we can connect this red pin to second terminal of resistor and black wire to cathode of LED. Connection is done. Then we can connect programming cable to Arduino to power it up, as well as we can flash the program. Yeah, that's it guys. We'll move to flashing.
First, this is the important step where we need to select first board. So here option that select others board, you can choose here Arduino Uno if it's already selected in my case. You okay, and also select the USB boards, that's USB ports, that is COM7. So this is the important step, because without this it's flashing, you will get the errors. For that you need to click on this terminal to upload. So before that, this is the compile and this is the upload. So while uploading, it will automatically doing first compilation, then will doing the uploading. If we now updated delay with a different value, so it will changing. For example, suppose I will make the delay of the 500 milliseconds, so it will the toggling should be fast up, toggling frequency should be speed up. We can check with the different delay values. So it will be compiling, then after that it will flash. Now if you see, the speed is the fastest compared to the previous one. If I reduce the delay further more, that 200 milliseconds only off and on, so it will be take up very fast, speed up. Now compilation is done. Now it's uploading code. Yeah, it's done. Now if you see the speed, it's too much fast. Now if we reduce the further to 50 millisecond, then it's too much faster than all of this blinking of LED. Okay, so yeah, we'll come back to 1000 milliseconds. There are different hardware configuration while interface LED with Arduino Uno via resistor. So which pin of the LED is connected to digital pin of Arduino? It's depend a specific configuration. So mainly two configuration. One is a current source configuration and another one is a current sink configuration. So above hardware connection that we have seen, that's in a current source configuration. It is as per the left side diagram that I have highlighted. So where anode is connected to the digital pin via resistor, whereas the cathode is connected to the ground. But in case of the current sink configuration, it's a different, where anode is connected via resistor to source voltage, that is a 5 volt, and the negative pin, that is cathode, is instead of connecting to ground, it's connected to the digital pin number 10. So whenever we have turned on the circuitry, that time the supply voltage passes to plus positive anode pin of the LED to negative pin to ground. So to turn on that respective LED from the pin, digital pin, we need to give the low. That means 0 to turn on that respective LED, whereas 1 or a high voltage when we are giving through this pin, the LED should be get turned off. So we have always confusion that which one should be preferred and why these two are the different ones. So practical approach is that if multiple LED will be connected to the Arduino, and all should have connected using the current source configuration. So in that case, so LED pin will be act as a source for the supply voltage to the respective LED, as negative pin of the LED is connected to ground. So in that case, whatever the current consumptions for that respective controller will be increased, which will may cause to damage of the respective controller, or it will be overhead to the respective controller. To reduce it or the safer side, we can use the current sink configuration, where the supply voltage will be the main source for the whatever the current consumption is required for all LEDs. So Arduino will just provide the grounds to respective LED to turn on or turn off that particular LED. So practical approach or the better preference way to turn on the LED will be the current sink configurations that we can prefer. So as we already saw, there is a current source configuration code. It's the same one. That's a high we need to write to turn on the LED, whereas the low to turn off the respective LED pin. So whereas the current sink configuration, the logic will be different, which is the most preferred configuration. To turn on the LED, we need to write the low on the respective pin. With delay of the 1 seconds, we need to write the high to turn off the respective LED. So we can see the practical way how it will be the behave. So to make the current sync configuration, we need to change the hardware connections first. For current sync configuration, we will change the on and off condition of the LED. So that is here low, and here we can make the high. So this is for LED on and this is for LED off. So that is the different, means opposite to the previous one, that is for current source configuration. So this is for the current sync configuration. We will play for a second, and if we change to, suppose I will reduce the on time to 500 milliseconds and off time will be the longer one. So this will be the behavior in the different way. So it will not differentiate the brightness or the blinking, because it will be the same, that 1 second off and 1 second on, because of this current sync or current source configuration. But it will means preferred configuration for the point of view to means safer side of the Arduino Uno, means our controller, as well as the LED also. So if you see, I have reduced the time to 500 milliseconds to turn on time, and the turn off time to 1000 milliseconds. So on time it's shorter than the off time is the longer one. For multiple LED connections, we are using current sync configuration, which will be looked like this way. Multiple LED are connected with the different digital pins of the Arduino Uno. So these are the program for multiple LED configuration, where multiple LED, that is red, blue, green and yellow, we have connected to the pin number 8, 9, 10, 11 respectively. These 4 digital pin we have used. Then we have used the declaration for the delay, so we can just update the delay here accordingly. It will update for other pin. All pin we have configured as output using pinMode functions, and then respective LED will be on and off will be did. first we did the on for all 4 LED, and then after that we have to make all 4 off. So if we flash this code, it will now change the sequence of the program. Now individual it's on and off will be happen, so that will be the first all 4 will be get on sequentially, and then after that it will get turned off once the code will be flash. Oh, then one by one it will get off. Starts 4, then will get off. So in this way we can change whatever the logic that we want. Either all 4 LED we want to turn on, or all 4 LED we want to off. So like that we can make the change of the loop functions according to our requirement. Suppose I have modified this another one logic where all 4 LED will be turned on once and all will get off once with a delay of the 1000 milliseconds. Once the code will be flash, it will update. Flashing done. All 4 are on and all 4 are off. Thank you everyone. If you have any queries or doubts, please feel free to ask us in comment sections. For more updates, please subscribe our channel. Thank you everyone for watching this video.